as what in the world is going on. So let's look at it. Let's see.
Wait, I have a question. Oh, so aside from like stuff in the calendar on Friday?
No, I think it was just a worksheet.
Oh, okay.
It was just that. That's all I put on there.
So then the book we're going from Thursday?
Yeah.
Oh.
It's really tough to pay attention when we do in class.
I'm scared. Yeah, you
All this on there. That's why I was wondering. Alright, so, ladies and gentlemen, we started Thursday here. Okay? Thursday we started with these guys. I believe we went, was it? We did say 45 through 50, correct? Or was it?
Yeah, it was.
Okay. So what I did with first hour is I kind of walked them through a few of these as well. And I did that with the worksheet, and I'll show you guys again, reiterate how we write the systems together. I think in this class, we started 45 together, didn't we?
We did 48.
Okay, we did 48 together, but 45, one of the things that people tend to forget with on this one is how do you work with inequalities to make your life easier? Now,
Convert that.
you can convert that. Yeah, what I would do here on that first equation, the first thing I would do is just rewrite it as x plus 2 is greater than or equal to y. But then I'm going to say it backwards. What I mean by that is this a true or a false statement?
True.
True. It says 3 is less than 5. If I say that backwards, it says 5 is greater than 3. That's true, right? So what happens when you work with inequalities, as you read them one direction, you read them backwards going the other way. Okay? So you do the same idea with this first equation up here, and you would have gotten y is less than or equal to x plus 2. Are we okay with that? The only reason why I'm putting that y value up front is because that's how we know to work with slope intercept. It's just easier on our brains.
I was just thinking you put the x and the y at the same sign so you could solve it easier.
You can do that if you want as well. That's not a problem. When I get stuff like this, a lot of times, then I would have a minus y. And then you would write as x minus y is less or greater than negative 2. It still works.
Yeah, I did that.
And it still works. That's fine. There's nothing wrong with that. Okay. In my head, a lot of times when I get to the graphing stuff like this, I think slope intercept instead of trying to manipulate. That's just me. What you did is perfectly fine. Okay. From here, I think I was making the suggestion that we always want to try to identify what our largest intercept is going to be first, and then scale it back from there. Of those three inequalities, which one's going to have the largest intercept?
Less than.
The 10, okay? So I know that x is less than 10. If I place 10 here, then I know that this one at the less than 10, that's going to be a vertical line through 10, so it's 10, 0. And what direction is x less than 10?
Left.
Correct, going to the left. So we scale that one first. Okay? Now if I go to my next one, the x plus y is greater than 1, what are your x and y intercepts for that one? 1 and 1, okay? Now here's how I go about trying to figure out scaling of where 1 is located. If 10 is here, halfway would be 5, wouldn't it? Half, that would be 2.5. So half of that would be around 1-ish. So if I scale that to be 1, this one here on the other side should also be 1, because I'm trying to scale them to be the same. I'm just kind of giving it a rough idea. 1, 0, 0, 1. Between those two, solid or dotted? It's dotted again. Did it go through the origin? No. What's 0 plus 0? Is that bigger than 1? It's false, which means it's true going up. Okay? And then lastly, we have that, now you graphed it as intercepts with your intercept stuff. I'm going to do it with slope intercept. We should get the same basic principle. And when I graph this one via slope intercept, I have an intercept of 2, a slope of 1. So I go up 1 over 1, so it should be here. And I'm just kind of scaling it through. And then this one would be solid. Okay? And then did that one go through the origin?
No.
No. What's 0 plus 2? Is 0 smaller than 2?
Yeah.
Yes, so you shave down. So you should have gotten basically, because your other intercept was here at -2, wasn't it? Yeah, that's fine. Yes, sir. You don't have to. It gets messy. I would stay away from that for right now. Just using those directional arrows is perfectly fine, because as we get through a little bit more of this, probably Thursday, from all intents and purposes, is when we're going to start doing a full-on constraint, and we want it to be as clean-ish as possible. That's why I'm trying to just do arrows for just small directionality stuff. Okay. And then as we get into Thursday, we'll start to find more and more of our where everything intersects. I know we did it hit or miss on a few of the problems throughout the day. Sometimes I'll pick, hey, let's figure out where these hit. Here, let's figure out where this one hits, but some of them I don't, because some of them are clean and some of them are just kind of crummy. All right. Let's see. So that was 45. 46, same basic idea. We've had a lot of questions about the idea of what happens when you have y is less than x or y is greater than x. A lot of people are tending to kind of mess around with that a little bit, and they're having some difficulty. So let's look at 46 real quick. Or, you know what? 7, you have intercepts of a whole bunch of zeros, but then you've got 1, 6, 5, 6, right? Okay. But do you guys also agree that there, in this case, there is a slope of 2? Y-intercept of 0, slope of 2. So this would be a good case to also draw it out as 2's. Or, yeah, we just do 2's. Notice I'm starting with the further out and then coming in halfway. Yes, sir. We do this a lot in Algebra 2, especially when we get to trig stuff, where we have to set what's called our period. If we know that your period is going to be one full oscillation, it starts somewhere and it ends somewhere. Halfway in between is halfway between that, and there's another one. This will allow us to scale pictures and drawings later on as we start to go up and doing all this kind of fun stuff. So, lots of stuff. Anyway, first one again, this is nothing more than, what is that? X is greater than or equal to y, so y is less than or equal to x. Be okay with that? So you got a slope of 1, intercept 0. Bless you. That one was a solid line. We used this point earlier at 2, 0. It didn't go through that. So is it true or false at 2, 0 for y is less than or equal to x? 0 is y, 2 is your x. Yes. So it shades that direction. Okay. Next one, same idea. This one has an intercept at 0 but a slope of 2. So if I do it that way, I know I'm going to go up 2 over 1. So, wait. And that would 2 over 2. Sorry, good morning. Let's try this again. I might look down 2 over 1. Hi. Driving to Wisconsin sucks. Did I ever mention that? Traffic on a Sunday is just awful. That's true, but we were west of Milwaukee, so it wasn't so bad. But just, if anybody's ever been to Wisconsin, when you leave Wisconsin on a Sunday, it's off, and everything's under construction. Every single road in Wisconsin is under construction, and it has been for the past 17 years. All right, so these guys are dotted. Okay. Hey, gee, look at that. There's a nice, easy test point again I can use. What's 2 times 2? 4. Is 0 smaller than 4?
Yes.
Yes. So it's shading that direction again. Okay. It's shading that way again. All right. And now the last one, your intercepts are at 1/5, 1/6. Is that okay with that? Cover and solve. 1/6, 1/5. X-intercept of 1/5, we'll say about here-ish and here-ish. Solid or dotted? Solid. Didn't go through the origin, did it? Nope. So, what's 0 plus 0? Is that bigger than 1? No. El falso, el true es verdad. True. That is true, right? Yeah, that's what I thought. I'm like, wait, I think I remember this. I remember some of my Espanol way long ago.
Yes,
That's verdad is true.
Yeah.
Es verdad. Cierto. Yeah. Like awesomeness is another name for me. The rest of these guys were pretty quick and painless as far as intercepts were concerned. It was just a matter of some funky regions you wound up with. Those shouldn't have been so bad, just scaling them through. Did you want either 49 or 50 or want me to go to the worksheet? Worksheet. Okay. So, on the worksheet then, I'll talk about what's that? What do you mean?
Like 12.
Oh, just find, no. Some of the, you could, if you found the intercepts of all those lines, that's great. That's just practice on how to do a lot of it. Some of them are clean, some of them are really awful. When we actually, yeah, when we get into the actual ones that we're going to have to find the bounded region spots, those equations and the inequalities become a lot cleaner. That's why I show you guys on some of them, because I know they're going to be a little bit easier than others. So it's no big deal. If you did it, great practice, no big deal.
Some told us we had to do it.
Oh, good practice. No biggie. Sorry. What happens then, as you find the intercepts for more than two equations, what you do is you figure out where that third equation hits the first equation. So, for example, if you did have to do that for like, and what'll happen when we get into the ones that have that, it's a lot cleaner because you'll have verticals and horizontals mixed in with some diagonals, and it's a lot. The bounded regions become easier. But if you look at one like this, you basically have three lines. Where do these two intersect? There's an ordered pair. Where do these two intersect? There's an ordered pair. Where do those two intersect? There's an ordered pair.
Wait, so
that's what it would do.
4.
Does that make sense?
Can you show it with 4?
And there's a lot more. But it's possible. It depends on the problems.
Oh, so I just.
It's really dependent upon the problem itself, not just each one is the same.
I did it wrong.
It's okay, don't worry about it, don't worry about it. So back on this worksheet then, let's see, where did you want, I'll show you how to do those at the end here, but where did you want to start in those first groupings?
6.
6?
Or 4, I don't care, I just got it.
4? Okay, 4 is 6, so we'll do 4. We'll start at 4. in here. inequalities, just add it to whatever page. You could probably put it on the back of that worksheet, these 4 problems here. If you want, please just take a quick picture of it, because I have not posted this PDF. This is a different one. This was one of those, I knew we needed a little bit more time. I wasn't sure quite yet, but just grab those 4 inequalities, the shaded region stuff, and we will do some more of this tomorrow. We will have a short, brief quiz on this come Wednesday, all about systems, solving systems of equations, graphing the systems of equations, graphing inequalities and things like that. We will revisit all that fun stuff manana and go from there. Good times. But like I said, I'll print this little PDF and I'll put it out. I'll put it on the calendar real quick as well. I can probably do that right now. Then you guys can do stuff. Just do this one.